Hello, everyone, and welcome to my talk of this year's adaptTo. I'm gonna talk a bit about the Cloud Manager pipeline, specifically that one for AEM as a cloud service. A few words about myself. So my name is Konrad. I'm working at Netcentric, and I'm passionate about open source. So I'm both member of the ASF and I'm involved in several projects there, namely Apache Sling and Apache Jackrabbit, where I'm a PMC member. Also, I'm an ACS AEM Commons committer. Before we start with my talk, to make it a little bit more challenging for me and obviously also for you, let's start with a little poll and let's see whether I can manage to do that. So pretty simple question. So the first question would be around whether you use AEM as a cloud service already, or you were still leveraging a classic, either on-premise or with AMS. So if you can just click on submit, and then I can close that poll. That gives me a little bit of an impression on how many guys of you do actually have on-hands experience. So I guess you see the results as well on your screen. So there is a majority who still doesn't have any experience with AEM as a cloud service. So unfortunately, the next questions are not that relevant for you guys any longer, but I would still be interested for those which do have experience with AEM as a cloud service to answer the following questions. So the next question would be, let me see how I can start this. So like this, you should see it in a second. Whether you had issues with automatic updates of your stage and prod environments, because the ultimate promise is that your stage and prod environments are always up to date and the most recent version of AEM. And unfortunately, in reality, that is not always true. Okay, I see that you have a similar experience in that area. Thanks for that. The next question would be around whether you ever faced any kind of regressions after an automatic AEM update, in case that happened, or even maybe after one you manually triggered via Adobe support. So about, yeah, some more on the yes side. This is a bit surprising for me, to be honest. I expected less issues there because, at least until recently, there were really very, very little changes, at least from my perspective, on the actual AEM product, and also deprecations that only started just some time ago. Okay, and the last question before we really start with my talk is about what kind of failures you ran into most often, in case you experienced some failures in the Cloud Manager pipeline. So which of the steps which are outlined here basically failed most often for you? Okay, so a lot of issues with deployment. I see that that is a bit unfortunate always, because the deployment is the last step. So it takes a very long time until you face, okay, there's obviously an issue. So that is obviously something you want to prevent. Hopefully, I do have some hints for you in my talk. And now let's really start with it. So first, a word of warning. So everything I say in these slides, so these are my statements and not the ones from Adobe. And all of this is based on my experience and based on observations. If you, for example, look very closely at the logs, you get a lot of internal information out of that, even though the actual documentation is pretty sparse, at least for those steps. I want to elaborate on. So take everything with a grain of salt. It may be that there are some mistakes actually in there. So if you spot some, please give me a hint. And also, it's important to notice that things may change anytime. So basically, with every future Cloud Manager update, it may work most probably not fundamentally different, but at least slightly different. So you should check that up front. So what I'm going to do is I'm going to basically highlight 3 steps of the deployment and build pipeline. And those steps are the build and unit testing step, then the build images step, and the last one is the deployment step. Unfortunately, the UI is a little bit confusing because the steps are actually named differently depending on whether you are in a dev or in a production pipeline. But hopefully from the names, it should be clear which step is really the deployment step. So internally under the hood, the Cloud Manager steps are aggregated into phases. So what you see here on the left-hand side, basically, of the screenshot is the phase name, and on the right-hand side, you see basically the step names. So the first step we're going to have a closer look on is the regular Maven build. Carsten in his talk already mentioned that everything is based on Maven, basically. The phase which is being executed is package. The operating system, the underlying operating system in the Docker container, in the build Docker container is Ubuntu. It's a slightly outdated Maven version currently. And what is important is that the JDK, which is used for building, and again, I'm only talking about the build phase here, only about the Cloud Manager and not about AEM as a cloud service itself. This is configurable nowadays, but by default, it's still the Oracle OpenJDK 8. So that leads me to the first best practice. You should always define an explicit Java version and make sure that your local build works with the same Java version. So there's basically 2 ways on how you can do that. So either you use tool chains in Maven, what I don't really recommend, and the other option is that you specify that in through a file, basically, which you put into the Git repository, which is named Cloud Manager Java -version. And in there, you can specify either 8 or 11. I would recommend to go with 11 if you start with a new project, at least. And that means that this is the whole build is running on top of Azul Zulu OpenJDK, which will in the future also be used for actually running AEM as a cloud service. As far as I know, right now, they're still using Oracle for running AEM as a cloud service, but this is going to change. The next best practice around the build phase is that you should clearly mark only one package container for deployment. This works with a package property where you say which one are relevant for the deployment via Cloud Manager and which ones aren't. A pretty recent addition were in the Cloud Manager were the support of Git submodules. So right now you can create multiple Git repositories in Cloud Manager, which is great if you have more complex, for example, team setups. And the basic idea is that you can, for example, use Git submodules to merge all of that together into one big repository, basically, which is being the source of your pipeline in the end. This is now really natively supported. So in the past, it was always necessary to have some kind of pre-processing outside of the Cloud Manager. Now you can do all that kind of aggregation within the Cloud Manager natively. And the last thing around the Maven build, what you should notice is that a lot of projects in front-end NPM-based builds rely on native libraries or binaries being there installed in a certain path. So this is often problematic because those might be either operating system dependent or might not be available at all in the Cloud Manager. So whenever possible, I would recommend to rely on NPM modules which are not depending on native libraries. So this was pretty simple. The next step is build images. This is definitely the step which is documented or not really documented, but there's a lot of complexity going on in this step, and therefore I think it's very useful for a developer to also know a little bit better what is actually going on during this step. So this step basically consists out of two phases. So the first phase would be that your build content packages from the previous step are being converted into Sling feature models, basically. And then those Sling feature models are used as a base for creating Docker images separately for author and publish. And then in addition, also for the AEM publish dispatcher. So let's have a closer look how that works exactly. So there's a tool which is being called CP2FM, which stands for Content-Package to Feature Model. And basically this tool consumes regular content packages, and out of that, it is going to create feature models, potentially multiple ones, depending on the run modes you're going to use inside the content packages. And those feature models consists out of OSGI configurations which are inline that feature models. Feature models are basically JSON files in that case, and also framework properties which are inside that JSON, and repo init statements inside that JSON. In addition, there are some basically dependent artifacts, binary artifacts, and those are referenced from the feature models. And those two type of artifacts we are dealing with here is either immutable content packages or OSGI bundles. Here it is important to know the difference between immutable and mutable content packages. So because AEM as a cloud service is running with a composite node store, the immutable content packages only contain content below apps and libs mainly, and more or less everything else is mutable content packages. Yeah, so this output is basically then used with the next phase. But before we come to that, some more hints on how you can actually leverage that tool already locally, because in some cases I experienced in the past that tool failed, and sometimes it is important to understand what really ends up in your feature models or why it exactly fails. So whenever you have a closer look at the Cloud Manager log, you can see an execution of CP2FM in it with the exact CLI argument. So let's have a look at what this means. So in this case, the default bundle start order is 20, and we are running it in verbose mode. That means you get a lot of output even in the logs. There is a thing called a seed feature, which is also available in Maven Central, more or less, which is the underlying SDK API OSGI feature. And that one already includes a certain set of OSGI configurations, including some repo init statements. And to make it possible to correctly create new repo init statements, it's important to understand what is already there initially. Therefore, you need to give that seed feature already at that phase to CP2FM. So the next one, which is important, is the output directories. CP2FM emits uses two different folders. One is for the artifacts, for the referenced artifacts, and the other one is for the feature models themselves. Then you give a generated artifact ID, which the feature will have in the end. You make some specifications around API regions. And the last thing which is given here is some package entries are just disallowed, so you shouldn't really use that. I'll come to that in a second. And the last thing you always have to give is basically the input content package from which everything is being generated. So after that step has been executed, you do have your application feature model. And this is being merged with the AEM base feature model, which is more or less provided in Maven Central. So if you're really interested on how, for example, AEM publish is being configured, you can have a closer look at that Sling OSGI configuration, at the Sling OSGI feature, which is being provided with classifier Sling OSGI feature next to the AEM SDK API. So those feature models, those two are being merged. This is being done by the Sling feature Maven plugin aggregate features. Again, if you want to, and if you have some issues with that, you can run it also locally to see exactly how the aggregation works and which, for example, configuration takes precedence and so on. In the end, you have an aggregated feature model, and this one is being used to actually start AEM for the first time. So this is a little bit controversial, this slide, I would say, because this might change, and this is pretty likely to change. So be careful if you rely on information I outlined here. But right now, this is more or less how it works, or how I figured out it probably works. So basically what it does, it will start AEM for the very first time. And basically all the immutable content packages are being installed during that very first startup. And as Carsten already mentioned, then there's some pre-compilation of client libraries going on in AEM, and some scripts are being pre-compiled as well. And afterwards, AEM is being stopped. Whenever you have some code which is automatically being executed during startup of AEM, or is executed through install hooks, it might be that it runs already at that point in time. So this is sometimes a little bit dangerous because, for example, you don't see all the mutable content at that point in time, because during the Docker build phase, AEM starts with a volatile mutable content repository. After AEM is being stopped, there is some kind of post-processing going on outside of AEM. So there is some cleanup on the file system being executed. And then there's some command line tools being used, for example, to convert any resource to Oak resource. And then there's compaction being executed. And finally, the Docker image is committed and pushed to a private repo. So you don't really have access to that. But it's important that this output is then being used in subsequent steps. Apart from AEM, you're also building Docker images, or Cloud Manager builds the Docker image. It's important to notice, though, that this is only for the publish. So in front of AEM author, there is no dispatcher. Again, this the configuration is being merged with kind of a base configuration. The good news, though, is that everything can be reproduced locally, because the dispatcher SDK can be downloaded and you can execute it on your local machine. And this dispatcher SDK comes more or less with the same configuration which is being used in production then in the end. Also, there is a validator tool coming with the dispatcher SDK, which checks that you use only the allowed directives, for example, and you don't use any other plugins which are not installed. The major pitfalls of this build images step is that whenever you execute some code there, you don't see the production mutable content. So you only see some kind of temporary content there. The repository is mostly empty below /content. And so as a general advice, I would say whenever possible, you shouldn't execute any code at that point in time. The next kind of pitfall is that only pipeline variables are available and no environment variables, which might be a little bit surprising, but this is due to the fact that, for example, for stage and prod, the very same Docker image is being reused. So it's being built separately for author and publish, but it's not being separately built for stage and production, for example. And this is related also to the last point here on this slide, which is around environment run modes, which are only supported for OSGI configurations. Also here, the hint, the order does matter. So you through list, author, or publish if you want to restrict it to one of those instance types, and only afterwards you specify the environment run modes like stage, dev, or prod. And as said already, this is not supported for OSGI bundles and sub-packages, so those are installed always on all environments. One thing I haven't mentioned yet, so you see a lot of words here in blue and underlined. Those are links, and the links contain some references if you're interested in the details. So let's talk about the last step in most of the cases, so which is the deployment step. So this step again consists sort of several phases. So first of all, there is the search index being updated. Then the actual AEM pods are being started, and only afterwards your mutable content is being installed. This is very important to know also, because it could be that you again have some code in which is being automatically executed during repository startup, which already relies on certain mutable content being installed there. Be aware of that order, because yeah, as I said, the mutable content is only installed sometime afterwards. So the mutable content installation happens on a dedicated Kubernetes pod. So what it does internally is it will download again the container package, which has been built in the first step, in the Maven build step, and will extract from that all the mutable content packages. And those are being deployed via the package manager REST API. Important is also that the deployment targets only the author environment. And whenever some package is also relevant for the publish, it's being replicated basically. but not directly installed from that mutable content pod to publish. We can see that this actually makes a difference in a sec. Yeah, let's have a closer look on how the index update works. Again, this is something that might change in the future. Hopefully you don't need to rely on that, but in case you face some issues with indexes, it's still very helpful to understand how it works under the hood. So the index update happens outside of AEM. There is some tool which uses OKPI directly, which is not AEM. And this modifies basically the segment store, the oak segment store and document store directly to contain the new index. What is important to know is that the index is being versioned. That means there's always 2 versions of the same index available, or at least if you had that index in the past as well. And everything which is older than the previous generation of the index is being purged because that one is no longer being used by any of the environments. This is documented also. So if you have some further questions around that topic, you find some information in the Cloud Manager documentation here. Some pitfalls on the actual deployment. One thing I mentioned already, or we had already covered in the poll, the initial poll, from my perspective, a lot of AEM updates unfortunately don't happen automatically, but need to be manually triggered through support. There's one known issue, which is that pipeline environment variables, whenever you use those, they prevent the automatic updates. That is a known issue and will hopefully be solved at a certain point in time in the future. And also one issue is that the update process, so the pipeline which is being used for the AEM update, is not visible to the customers. So you don't really see if it fails. And to me, it's not 100% clear how the communication works, but maybe this will also improve in the future, and hopefully it will. Next thing is mutable packages. So you need to be aware of that. For example, if you want to include install hooks in mutable packages, those are just not supported on the publish. And the reason for that is that under the hood, a service user is being used, and this one doesn't have the rights basically to execute any of the install hooks. So whenever you have some mutable package which is relevant for publish, it will fail if it includes some install hooks. And the next kind of limitation is related to that as well. Some repository paths are read-only for that service user, which is being used for package installation on publish. So if you want to modify something below var or temp, you cannot do that by default unless you change the privileges of that underlying service user. And then the last thing I mentioned here is the limitations on index definitions. So index definitions should follow a certain naming format, basically. And also it's important to notice that only Lucene indexes are being supported with AEM as a cloud service. And also, I don't know whether that's already live, but the documentation mentions that already. In the future, there won't be any standard full text index available. So if you rely on full text in your application, you have to come up with your own custom index definition for that. Some key recommendations to prevent falling into the pitfalls, basically. Use the Maven tooling, which is available. I want to highlight 2 different plugins. One plugin was already mentioned by Carsten, which takes care of that, basically everything around OSGI is proper and in shape. So for example, Java code, most UI configurations, and some other stuff. And the next one, or the second tool, is AEM Cloud Validator, which is a Maven plugin, which takes care that the content packages have the right format. Also, my recommendation would be to set up a customer CI next to Cloud Manager, so not relying only on Cloud Manager for doing continuous integration, but set up something next to it, because the round trip times of Cloud Manager are pretty bad still. So to get a more fast feedback on whether your build is actually successful and will be successful in Cloud Manager, I would recommend to perform as many checks as possible during locally, obviously, and then also in the customer CI, which, for example, might be a Jenkins. And if you set up something next to Cloud Manager, something central, it's also important that this one should automatically trigger the Cloud Manager build if it's successful, and also that you have all the relevant information at hand. There is obviously a Cloud Manager API, which exposes all the information you otherwise only see in the Cloud Manager web interface. So there's even a Jenkins plugin available, which automatically exposes that in Jenkins if you leverage that. Last words around references. Most of the references are inline links, so you just have to click on those in the slides. And additional references are the two ones being listed here. So the first one is from CQ support, which has some hints on how to debug stuff, especially around deployment failures. And the other one is a former adaptTo talk around how the deployment to the hood. And we do have, hopefully, some time for questions. Let me open the right tab here. I don't see any questions. It could be me that I'm too dumb, or there aren't yet any. Let's wait. If you do have some, please share them in the Q&A tab. Good. So if there isn't anything obvious, I think I'm gonna close the session now, and I wish you a lot of fun with the remaining adaptTo talks. Thanks a lot.